So hi everyone, I'm Brad Topol. I'm IBM's Distinguished Engineer for Open Technology and Developer Advocacy. I'm also a Kubernetes contributor, a doc maintainer, and I'm the Kubernetes SIG docs localization work group chair. And today at Open Source 101, I'm here to give a nice introduction to Kubernetes. So this is great 101 material. Thank you all for joining. I have things set up, so if you want to enter a question while I talk, you can actually do that, and I'll be able to see it on my iPad. So I can take questions while I'm doing the presentation, and I don't mind doing it. It usually makes it for a better presentation. So we're going to talk about Kubernetes, which is a platform that does management of containers and container orchestration. But before we get into Kubernetes, we really need to understand what a container is. So we're going to spend a few minutes on that. And so the best way to do that is we're going to go in the Wayback Machine to around 2012. So in 2012, when folks like myself were working in cloud environments, cloud platform environments, what we were using in the cloud platform environments were virtual machines. And so the cloud platforms would be responsible for getting the virtual machines up and running. And life was pretty good. How could life get any better? Well, in 2013 at PyCon, a gentleman named Solomon Hike showed up, and while the rest of us were doing things with virtual machines, which were really pretty big and heavyweight, he gave a presentation where he basically said, hey, all you folks that are using virtual machines, let me show you a different approach. I have an approach where I can provision my applications in an environment where, unlike a virtual machine, I can actually do things where I provision applications that are based on Linux processes, because the security in Linux has gotten much, much better. And I can take advantage of all these advanced security features so that I can take the processes and I can isolate them, and they can have their own little file system and their CPU resources and memory resources. And it'll look and act as if it's like a mini virtual machine, but it's really just a process. So it's much lighter weight, and we can put a lot more of them on a machine, and we can start them up real fast. So here was the rest of us doing things with virtual machines, and when we wanted to start up a virtual machine, it took a while. And when we wanted to snapshot the virtual machine, it took a while, maybe orders of minutes. And here comes Solomon at PyCon showing us an approach that provides similar features. You could snapshot images, but it was process-based, and so it would start up in a couple of seconds, whereas we were used to starting up in a couple of minutes, and it was much lighter weight. And he built it so that it was based on a file system approach that was a layered file system. So when he showed how to snapshot the image and snapshot the progress, all it had to do was snapshot the differences between what was new in the file system. And so his snapshots were really, really fast. And compared to when you snapshot a virtual machine, you have to snapshot the whole machine. So it was an incredible demonstration of capabilities. And he said he was going to make this all available, and he called it Docker. And what he called that process with the security and its own resources, isolated with its own CPU, memory, and file system, he called that containers. The other nice feature he showed is the containers would package up all the libraries they needed. All the code the process needed to run were packaged up, and whenever the container would run on a different machine, it had everything it needed. So it wasn't relying on the host machine to have the libraries it needed, which could potentially be a different version, which could potentially have problems. So it was really incredible what happened in 2013, and the world of containers and Docker became about. So looking at this picture, you can see the difference between running on a Linux server with a lot of containers compared to running on, say, a Linux server with virtual machines. The first thing you'll notice is the virtual machines, they have their own application, but then they have their own virtualized Linux kernel. So if you look at how the applications run, they got to call through the virtualized Linux kernel and then go to the actual Linux kernel. And so each one is carrying a lot of stuff. So on a server, you can only get, say, a few of these because they waste a lot of resources. But if you look at the container-based approach, the containers have their application and their libraries, but they all share the same Linux kernel. And so they're not going through a virtual kernel and going to the Linux and then to the real Linux kernel on the server. They're just using the actual Linux kernel. And so this results in an approach where there's not as much waste, right? You can store a lot more containers on the server. They don't each all have their own virtualized Linux kernel. So there's not all that waste there. And you can really get a more efficient approach to provision the applications and getting things up and running. So this was a huge step forward. So now that we have the concept of containers, now we need a way to manage them. We need to provision them across a cluster. We want to be able to scale them. So many features that we want to do to actually run this as a cloud-based platform that can run containers. And something needs to manage all those resources. And Docker, that company that was started by Solomon, well, it had its approach. It was called Docker Swarm. But Google had actually used a similar approach for a large number of years, similar to their sort of container-based approach. So they had figured out those same ideas, and they had already built systems to manage containers. They built multiple generations of systems. They had one called Borg, one called Omega, and then they had a newer one called Kubernetes. And so, believe it or not, even back when on Google, let's say you had Google Mail or whatever Google application you were using, those all ran as containers in their infrastructure, and they worried about managing them, scaling them, what have you. And so Google decided, well, you know what? We should take our platform, which was called Kubernetes, and we should make it open source. And so this was now a platform that was available that would manage your resources, manage your volumes, manage your network, manage your configuration secrets. And it had what was called a declarative model. We'll get more into what that means. But it basically enabled you to say, I want to declare what I want to happen, and Kubernetes will make it happen. I describe what I want, and Kubernetes will figure out how to give me the desired state that I want. And so what happened is Google made Kubernetes open source. But what happens with open source projects is if you really want to get a lot of traction and adoption, people are a little nervous about what we call single vendor open source. So they want an open source project that has a lot of vendors that contribute to it. And they also want an open source project that ideally has a foundation behind it that can provide some governance and can provide a level playing field for contribution, which means anybody that contributes a lot to the project should ideally grow and have the opportunity to have influence on the project and influence on what the project's direction will be and what features it'll support. And that's what happened. So a large number of companies got together, created what was called the Cloud Native Computing Foundation. Um, Kubernetes was donated by Google to be the seed technology for the CNCF. And that drove the huge amount of adoption and growth of Kubernetes by a large number of companies. And so the CNCF has actually grown to having 440 member companies. It now hosts 26 open source projects that are all somehow related to Kubernetes in one form or another. And they do conformance certification. And so over 100 vendor distributions of Kubernetes have passed conformance certification tests. So thanks to having a great platform with great features and having a great open source multi-vendor approach with a foundation behind it, this is sort of a winning formula for a very successful open source ecosystem, which is surrounded now Kubernetes. So let's start taking a look at the Kubernetes architecture. Basically what Kubernetes does is it runs across a cluster of servers, and it's going to enable you to run your containers across that cluster of servers. Now, looking at the architecture chart, you'll see that there's a master node, and you can interact with that node through a user interface or a REST API or a command line interface called kube control. And you can use that to get your containers up and running on a large number of worker nodes. Now, what Google had learned by its platform for managing containers is typically um, you want to manage containers in pairs or more than one container. Certain containers are related and they should all be managed together. Maybe they all run on the same server, what have you. So what Kubernetes decided is the container should not be the smallest deployable unit. It came up with a new concept called a pod, and the pod would contain one or more containers, and that would be the unit that Kubernetes would worry about managing. So if you look in this architecture picture, what you can see is we've got two worker nodes, and each worker node has multiple pods on it, and each pod can have one or more containers inside of the pod. Now, if we look at what a pod, let's really learn a little more about it. Again, it's a collection of application containers, and it can include their volumes, and they all run in the same execution environment. And these pods are the smallest deployable unit of a Kubernetes cluster. And so the way you should think about it is applications that are in the same pod, they actually share an IP address, and they share a port space. They share the same host name. Those containers inside the pod can actually communicate with each other using native inter-process communication. And they can also share mounted storage. Now, if you have two container applications and you put them in different pods, well, they're going to for sure have different IP addresses. They're going to have different host names, and it's going to be as if they really are running on different servers. So when you design your pods, the big question you need to ask yourself is, will these containers work correctly if they land on different machines? And if the answer is yes, they'll be fine if they land on different machines and work correctly, then they really should be in different pods. Um, Another great example of mapping of, well, do you put things in the same pod or put things in different pods? Think if you have a simple web-based application where you have your web server and a database. So one of the questions we would ask is, well, do you put the web server and the database in the same pod or put them in different pods? Well, really you want to put them on different pods, because one of the things that Kubernetes gives you is scalability. And you typically want to scale your web servers up to a higher number than, say, your databases. And so by breaking them into different pods, you can control the scaling, the number of copies of the application. So that's a good example of where you would design putting the containers in different pods. So let's talk about the features of Kubernetes pods. Um, Basically, Kubernetes is going to give you the ability to create pods, list pods, delete pods. It allow you to run commands in your pod containers. It allow you to copy files to and from the containers in your pods. It allow you to test and connect to from your local machine to your pods that are running inside Kubernetes. And it also has what are called liveness and readiness probes. So one of the key reasons people love Kubernetes so much is, unlike previous cloud platforms, Kubernetes put a lot of effort right into the default capabilities of being able to do things like, I'm going to worry about running large numbers of copies of your application. And so I'm going to be very good at scaling. And I'm going to worry about whether some copies of your application fail or not. So I'm going to be checking to make sure that, let's say you have 5 copies of your application and you want 5 copies running. I'm going to keep track that there's 5 copies running. And if I notice 1 or 2 crash, I'm going to actually start more up. And similarly, if I notice that your copies of your application are getting overloaded, I have built-in auto-scaling. So I'm going to be able to scale more copies up if your system gets overloaded. So why do your cloud platform operations folks love these features? Because if they get their applications up and running, and maybe it's the holidays and the sales are going to really ramp up, and so you got to worry about excessive load. Well, Kubernetes is going to handle that. And also maybe part of your applications crash, maybe a server crashes. Kubernetes is going to handle starting up new copies on different servers instead of your pager going off in the middle of the night. So Kubernetes is going to take care of a lot of features that you need, and that's why people in operations love it so much. Now, if you remember earlier, I mentioned that Kubernetes is a declarative model. So you get to declare what you want, and Kubernetes has to figure out how to make it happen. And the declarative model that it uses is a YAML file-based specification approach. And we can see a simple one here over here on the right. What we're seeing is a YAML file. And the first thing we put in it is we declare the API version that we use. V1 is fine. Kubernetes is always changing over time, new features. So newer features come, you pick the API version that you need. The other thing is it has different resources that it manages, and the version that the simplest resource that it has that we're going to talk about first is the pod resource, and so we give it a kind. Um, um, and I'm going to stop and just take a quick question from Grant. Great question. Are Azure and AWS copying the success of Kubernetes, or are they different in a significant way? No, the beauty of Kubernetes is it is running and available on both Azure and AWS and IBM Cloud and Google Cloud. So they aren't really copying the success. They're all running Kubernetes. And remember how I talked about how we have all these conformance tests? Well, that helps to make sure that your workloads are portable. So you could start on one platform, and if for some reason you don't like it, you could move to a different platform. And you can actually, we call it hybrid cloud, you can run on multiple cloud platforms. And that's happening more and more as well. So Kubernetes, because it's so portable, it's now available as something you available on all those different cloud platforms. Grant, hopefully that answers your question. So going back to the example here, again, the simplest resource that we have is a pod. We give it a name, so this is what we want, and then we give a specification. What do we want to run? What's running in our pod? And what we want to run in the pod is a container. We give it a name, Nginx, and then we give it a Docker image. So what's the image that we want to run as part of the container? We're going to run Nginx version 1.79, and it's going to need to have exposed the container port of 80, because that's the port it runs on. And so we take this specification and we run this kube control command at the bottom here. And this specification gets fed into Kubernetes, and Kubernetes goes, oh, I see you want to run a pod. I see you want it to run the container Nginx. I see which version of Nginx, which container image you want. I'll go make this happen for you. So the declarative model is what happens, and you just give it the specification. Here's what I want. Go make it happen. And so this is a simple one, but let's look at one that's a little more powerful. Again, I talked about Kubernetes being willing to worry about creating and managing and checking on the health of multiple copies of your application. And so the way it does that, its resource for doing that is called a replica set. And so a replica set runs across the cluster, and you can see it in red here. You get to say the number of copies of your application, basically the number of copies of pods that run your container application, to be specific. But you get to tell it how many copies you want. And the replica set is what we call a controller that is going to manage and make sure that it starts up the number of copies of your application, and it's going, if any of them fail, it knows you want 3 copies. It's going to make sure there's always 3 running. So it's always going to be checking on the health of those as well. And so you can see visually what this looks like. A replica set is going to have 3 of the same pods, and the pods each have, say, the same containers inside of them and the same volume mounts. And so let's look at how we do our description. Again, declarative model. We're going to write a YAML that declares what we want, and Kubernetes will make it happen. And so what we want is a resource of type replica set. We're going to give it a name. The name is front end, and we're going to use labels. Labels are just key value pairs. And amazingly with Kubernetes, so much work is done by key value pairs labeling because, again, Kubernetes always assumes that problems are going to occur, your pods are going to crash, and so it may start with 3 pods, but maybe there's not always 3 pods. It's going to assume bad things can happen. And so it uses these labels, and your pods get labels, and so a replica set knows which pods it manages by what labels are out there on the pods, and it says, hey, I'm managing the pods that have certain labels. And we can actually see this in the specification here. So for example, the first thing we see is that it's going to say there's going to be 3 replicas. So we know it wants 3 copies of whatever the pods are. And then it's going to say, well, which pods do I match? And I'm going to match for the key tier that has a value of front end. Okay, so we know what it wants to match, but we got to make sure those labels get into our pod. So what's nice is in the same specification of what the replica set is, it also gets to describe the pods that it's going to manage. And so it makes sure down here under template, now we're describing the actual pods that are managed by the replica set. And here we get to say, well, it's going to have the labels of guestbook and app. The key is app and the value is guestbook, and the tier key has a value of front end. And those are important because if you look, that's what it's going to look for, pods with those labels. So you might as well make sure those get applied. And then down here under the specification, you get to give the name of the container, and you get to give the actual image of the container. And again, you get to say what port is exposed by the container image. So in this single specification, we're able, for replica set, we're able to say, we got to have 3 replicas, and we get to say what's in the actual pods that are going to be managed by the replica set. And then we have our favorite command here at the bottom, the kube control create, passing in that YAML file. We pass in that specification. Kubernetes is going to say, oh, Brad wants 3 replicas. Here are the labels that should be on each of the pods. Here's the image that should be running as part of the container in each of the pods. I better go make this happen for Brad. So thanks, Kubernetes, for doing all the hard work. I just give the desire of what I want. So if we go into the replica set, we had our first specification that I showed you, but the beauty of it is we can update that specification. So we started with 3 replicas, and now we can update the value to 6. We're going to leave everything else the same. And if you look at the bottom, we can use the kube control apply command. And what that allows us to do is update the Kubernetes with this new version of the specification. And with the new version of the specification, we tell it we want 6 replicas. And so guess what? Kubernetes knows it has 3 running, but now I said I want 6. Can anybody guess what Kubernetes is going to do now that we've sent it the value of 6? I'm going to answer for you because I know you know the answer, but it's going to scale it up from 3 copies of your application container images to 6, which is really cool. And so replica sets have some built-in functions. They're easy to delete. They can also delete the containers that they manage. But the really cool feature is down here at the bottom. The replica sets have built-in support for what we call horizontal pod autoscaling. So if we look down here, let me interpret this for you. Um, we can say, listen, we want you to auto scale, start from 3, go up to as many as 7 copies, and do it when the CPU percent utilization hits 80%. This is a wonderful feature because if you've ever seen any of the cloud platforms that existed before Kubernetes, anytime you wanted to do auto scaling, you were typically building your own auto scaling capabilities or building your own fault tolerant robustness capabilities. The beauty of Kubernetes is it's all built in. You don't have to roll your own. And so this is incredibly powerful. Now you think replica sets are great. I'm going to use those a lot. Brad just showed me the power. I can't wait to use replica sets. The truth is you're never going to use them. Well, why am I not going to use them? They seem really powerful. Well, the beauty is there is another type of resource that Kubernetes has that's just like a replica set and does all the work that a replica set does for you, managing multiple copies of your pods, but it also gives you great support for managing the release of new versions of your container application. So, right, remember, life cycles aren't just we get things deployed once. We're typically having to deploy new copies of things, right? New versions of things. And so that's what the deployment resource allows us to do. In fact, we can look at the visual over here in the bottom left. Really, you can see with a deployment, we've got actual multiple replica sets where there's different versions of our application running, and we get to worry about how we deploy the new version, right? So we can deploy it slowly. We can maybe just put one new pod out there and while all the old pods are still running and see if anything breaks. Or we can do what's called a blue-green deployment, where let's say we've got 3 copies of the old version, and we're going to first bring up 3 whole new copies of the new version before we get rid of the old one. That's called a blue-green deployment. The Kubernetes deployment capabilities allows us to do all of that and through a simple declaration. And we'll go through this and what this looks like. Again, just to show you, we can still do it. We can change the number of replicas from say 3 to 6. That still works. Um, and at the bottom here, you'll see that we still are able to, like a replica set, describe what our containers are and what their labels are. So we do all that. And our deployment has its labels as well. So all that's still good. But now we've got some new values. How to do our rolling updates. So we get to tell it our surge value and what can be unavailable. And so a surge value tells us things like, okay, well, we started with, say, let's say we've got 6 copies and we want to update all 6. Well, we can also have surge value of here's some extra copies that make it easier to upgrade. So I don't have to sort of only have a total of 6. Let's say my surge value is 2. I can have now a total of 8 copies where, say, at any given time, more and more of those 8 copies are the newer version compared to the old version. I also can say how many are unavailable. And so if I want to be, I can tell Kubernetes, listen, you can't make too many of these copies unavailable while you're trying to roll out the new version, because that's really going to hurt my performance. So I get to say, listen, maybe at most 1 copy should be unavailable. And between those tools and then some deployment commands, you have a lot of power and flexibility of how you deploy the new version of your application and get it up and running. So if you look at the bottom here, I can pause the deployment. I can resume the deployment. I can check the history of how it's deploying the new copies. So there's an amazing lot of power in what's going on there, and as it rolls out new versions using the deployment constraint resource. So now we've shown that we have some great Kubernetes capabilities to manage multiple copies of my application. It can also worry about deploying new versions of my application. but it's also got what's called a Kubernetes service object. And basically it's got a built-in load balancer. And you might ask yourself, why does it need a built-in load balancer? There's a lot of load balancers out there. Well, again, remember, Kubernetes already assumes that your pods will be up and running, and then they're probably going to crash, or even a server's going to crash that the pod runs on. And it's going to be responsible for starting up new copies of your pods, of your application on different server nodes. And so it needs to keep track of really where your pods are running, because where they run over time is going to change. And a standard load balancer doesn't know how to do that. Standard load balancer doesn't worry about those issues. So Kubernetes provides a built-in one called a service object. It's assigned a virtual IP address called a cluster IP. And through that IP address, you can get to any one of the copies of your application pods, and that cluster IP address is stable enough you can actually hand it over to a real load balancer, a real one, and so you get all a DNS service can expose your pods. Again, the readiness checks are built in, so it's smart enough through its load balancer to only send traffic to the pods that are up and running. And it's really simple to use. Again, here's a simple command to create an Nginx deployment with 3 replicas. And so we're going to create a deployment in one real simple command here. And then we can create a service for that deployment. And we can even say the load balancer is running on port 80 and connecting to the containers that run on port 8000 by doing a kube control expose command, which will expose the deployment and expose and create that service object for all our pods. So Kubernetes service objects are very powerful, and they help us do that. One of the great things about Kubernetes is that declarative model. So what happens is the YAML files are declarative. And if you're used to using containers and Docker files, well, the Docker files describe how to build your Docker images, your container images. And so next thing you realize is pretty much everything you have, you can describe in configuration or declarative files, whether it's the Docker file or the Kubernetes declarative YAML files. So what does that mean? It means now you can control all your configuration changes. You can put all that in a source control, right? You can put that all in a repo or what have you. And now you can do continuous delivery, because you can push changes to a repo that are not only for your application, but that also describe how your application is configured and deployed through the Docker files and the YAML files. And now we've got a model where we can really do continuous delivery, continuous integration and continuous delivery. And this is really powerful. It's one of the neatest features that you get by moving from, how we used to do it in the olden days. In the old days, we would use, say, you had your virtual machines, maybe you were running OpenStack and you were using Chef or Puppet, and you had all these scripts. And so you'd have to go read the scripts to really understand how things were working. Here now, you can just go read the declarative files, and they're all stored, and you can see what changes are made. And so now we can look at continuous delivery capabilities where we're going to have small batch changes. We're going to source control all these code and configuration files. And as a result of all of this, the developers are going to have access to production-like environments thanks to the containers bringing all the libraries with them. And we can expose early on in the development process logging and change management and do a continuous integration of all the changes. And the result of all of this is you really can start talking about DevOps and doing continuous delivery. And that's not for this presentation, but just to understand that this now becomes capable because we've gone to this declarative model. So a lot to learn on those capabilities, and it makes life really interesting. Again, Kubernetes, one of the key features is auto-scaling. There's some simple code here on the right where we get our application up and running. We expose the service. We then declare the auto-scaling that we want. We're going to start with 1 node, a minimum, go up to 10 if CPU percent utilization hits 80%. And then the bottom here is a little command to generate some artificial load. And you could actually run this, and you can see Kubernetes over time will respond to the load and start up new copies of your application um, to support the auto scaling. And so that's the horizontal auto scaling. There's other ways to scale as well, but sort of beyond this beyond this presentation. But again, a great feature. And we're getting close to time here. We're getting a little bit of time, but we've also got free material, on how to learn Kubernetes, and so we have some free courses available. So these are courses you can take. You can earn a badge. You can learn about what's going on and go earn your badge. Um, Now, let's say you also want to go a little bit farther. Maybe you've learned Kubernetes and maybe you want to become a Kubernetes contributor. So now you want to learn how to be an open source contributor for Kubernetes. We actually, IBM, provide a free digital developer conference course that is available at the link below. And what we did is we went and had an initiative where we wanted to train a large number of IBMers to become open source Kubernetes contributors and become influential contributors and become Kubernetes maintainers. And so we had what was called the Dojo training course that we used to fly around to all the labs and train IBMers on how to become a Kubernetes open source contributor. And these are very skills and demand. Um, and yeah, I see. We will make sure I'll get this whole presentation shared, so you'll get all the links, Javier, from the presentation. I'll work with the moderator to make sure we get the whole presentation shared. You can also just take a quick snapshot for the few URLs if you're really interested. And there's a few key ones. But so feel free to take a snapshot. And again, why this is great. So we were going to go travel the world and go to each lab. We'd spend a week training with our top experts, fly them in. But guess what happened? COVID hit, and so that original plan had to be scrapped. And so what we did is, well, we can't travel everywhere, but we still need to ramp up our Kubernetes contributors. Let's make this a digital conference. And we actually recorded all our top contributors for the top areas of Kubernetes giving educational presentations for a variety of topics. And we actually did it live. So there's actually people in the audience, the virtual audience, and asking the questions. So you can go through the same digital course, and it starts out with things like an overview of Kubernetes. It then talks about the Kubernetes community and the contributor resources you can find there. We also teach you how to do Git and GitHub. So, some people are at different levels in their journey. If you're not really good at Git and GitHub and how to use it, we teach you how to do that. We also show you how to set up a Kubernetes development environment. And then we'll walk you through actually many of the Kubernetes main repositories. We'll show you how the Kubernetes community does their pull request workflow. We're going to teach you how to do test-driven development. We'll teach you how to grow your eminence, right? So we'll teach you things, how to behave in an open source community. A lot of it comes down to don't be a jerk, be nice to people, be helpful, try and do things in the community that aren't necessarily the glamorous jobs, but how to do things that people find valuable, like bug triage or fixing documentation. We like to call that chopping wood and carrying water. So we talk about how to be a great contributor. These are all videos that you can go watch. We show you how to do the pull request. And then on the last day, we've got all the advanced stuff. If you want to learn everything you want to learn about Kubernetes schedulers, Kubernetes networking, Kubernetes storage, Kubernetes extensibility, all of that is available and capable for how to do things. So feel free to check this out if you want to be an open source contributor. I also have a free book available. So in the before time, and hopefully we get back to it soon, but I've been a frequent presenter at the All Things Open family of conferences, whether it's All Things Open or Open Source 101. And next year, hopefully, when we get to be doing these in person, we typically typically do a book sign and hand out free copies of my Kubernetes book. It is available online. So you can at least get it there. And hopefully next year we'll have copies to hand out, and we'll be able to do signing copies as well. But a lot of what I've covered in this presentation is covered in this book. It's available, Compliments of IBM. Also got a new book coming out on advanced Kubernetes, the version of Kubernetes that's enterprise and very secure, called OpenShift, but that's a couple months away, so I'm not going to highlight that here. So we'll make sure we get all of this out and available. And in summary, again, Kubernetes has become the de facto standard for orchestration and management of container-based cloud-native computing applications. It continues to experience rapid growth and adoption. It's got this declarative model that we talked about. It's got built-in support for autoscaling. It's got a fantastic networking model. So that was one of the key advantages that Kubernetes had, is each pod has its own IP address, and that model worked really well for people. Again, health check support, great open governance, and some great links you can go try. Lots of places give you free access to Kubernetes. The IBM Cloud will give you a free trial Kubernetes, a one node cluster. You can register and kick the tires and try all these commands. And then we showed you the courses that provide you in a test environment as well. So that's pretty much it for our 101 material. We've covered a lot of the basics. And this is really a good time for questions. Just got a few minutes left for questions.
Thank you, Brad. That is
Sure.
a super interesting one.
Yep.
And maybe everyone would be more interested in getting the book and studying it, running some examples from that.
Yep. And so Ota, I need to work with you on how we get the presentation. The other, and once we figure that out, I am available on Twitter at Brad Topol, and I'll be happy to tweet that out as well. But Ota, do you know how we are able to what's the best way we're making the presentations available for the conference?
Yeah, maybe the chair would email you asking to share, and then she'll somebody will just post it on the website for attendees to get it from there.
Right. So we'll make sure to get that available. And the other thing is, if you want to follow me if you want to contact me on Twitter, or I'm available at btopol@us.ibm.com, btopol@us.ibm.com. And if you want to connect, or you just connect me on Twitter, we can DM each other. I'll be happy to get your email address, and I can be happy to email people a copy of the presentation as well. So again, available on Twitter at Brad Topol is an easy way to get a hold of me. I'm very easy to get a hold of. In fact, I should have done this. I'll type this in here too. My bad, folks. So we'll do this in real time. Oh no, horrible. btopol@us.ibm.com. And how's that? So you can reach me either of those two ways, and we'll make sure folks can get access one way or the other presentation. Always happy to share it.
Okay. We have last 3 minutes or a couple of more minutes to, let's see what people would want to say.
Mm-hmm.
And then a Q&A, someone was asking how agnostic is OpenShift in terms of what Kubernetes is to run it on.
Okay, so I see some questions here. Awesome. So if a cluster is a collection of nodes, what makes for a one node cluster? A one node cluster is going to be essentially two servers, two nodes. One node, you're running the master code. And we can talk about what that is. That runs what's called the API server. And then one node's going to be, the one node cluster is going to be the actual worker node And let me go to the architecture chart, and we'll show the architecture chart. So one node cluster would actually be the two clusters where we've got the master node and we've got the one worker node, and different parts of Kubernetes run on each piece. So what happens is that that YAML we talked about comes into the master node and runs on the API server, and the server then interprets it. And what'll happen is eventually you get down to the scheduler. The scheduler is going to worry about which of the worker nodes the pod should run on. And then over on the worker nodes, there's a kubelet, and that's a piece that actually is responsible for running those containers. So that's what makes for a one node cluster anonymous attendee. That would be one worker node and the master node. I hope that answers that question. Okay, how agnostic is OpenShift in terms of what Kubernetes distro to run it on? So the beauty of OpenShift is it also, like Kubernetes, runs on all the platforms. So OpenShift runs on Azure, OpenShift runs on Amazon, OpenShift runs on Google, OpenShift runs on IBM Cloud. So what's nice about that is it gives you an even more advanced version of what we'd call portability, workload portability, because you're guaranteed not only to have the same Kubernetes environment, but you're also guaranteed to have the same tools for continuous delivery, and what have you. Now, what OpenShift does that's a little bit different is a couple of things. One, OpenShift is going to run a very secure Kubernetes environment. So if you run an enterprise, if you run a bank, if you run an insurance company, and you need a very secure environment, OpenShift is going to force your environment to be, it is a Kubernetes, but it's Kubernetes that out of the box provides guardrails. So it's going to keep you from doing something that you're really going to regret in the future. So for example, Kubernetes out of the box will let you run everything as a privileged container. It doesn't care. And if you want to run your containers as root, and somehow the system gets compromised and somebody gets access to its application running root, well, that's kind of your problem. OpenShift out of the box is going to say, no, I'm not going to let you do that. I'm not going to let you develop. I'm going to make sure your developers are running containers that run non-privileged. And so OpenShift is going to worry much more about making sure your Kubernetes environment is very secure. And if you do things that are kind of not what you do, I say things that you're going to regret, it's going to prevent you from doing that, and your stuff's all going to run very secure. The other thing that OpenShift gives you is a lot of tooling for folks that aren't really good with, say, Docker commands, people who don't know a lot about containers. It's got what's called source to image, and it's going to allow, say, like a Java programmer or a J2E application programmer to get up and running and get their code into a container and deployed much faster than if they got to learn all the deployment stuff themselves, and not be in how to build an image and find a base image, add their code, merge it into a new image, put it into a registry. OpenShift is going to take care of all those details for you, where vanilla Kubernetes doesn't.
All right.
Hopefully that answers that question. How are we doing on time?
Yeah, we are done.
Oh, we're
with
done.
The Q&A
Oh, wow.
time, and yeah, we are right on time.
Oh, wow.
Thank you everyone for attending this second in the row for Technologies 2 track. The next session starts 2:45. Thanks, Brad, for the wonderful talk introducing Kubernetes for all, and we have a follow-up Kubernetes session by Brent after this. Thank you.
Great. Yep. And thank you everyone for attending. Feel free to connect with me by email or by Twitter. If you have follow-up questions, we'll happily point you to all the right, the courses, the free courses, the free training, and give educational environments to get you up and running with Kubernetes. So thank you all very much.